Okay, so part two. So apparently my face does show up. Sorry, you guys are gonna have to look at me for a bit longer. So uh, we were just done with number four. So we're gonna scooch on down. Let me move my face. We're gonna scooch on down to number five. So it says, state if the triangles in each pair are similar. If so, state. How do I know? Complete the similarity statement. Okay. So what we want to do here, so we're looking at five. So the first thing we want to look at is identify what the two triangles are. Okay. So we've got this triangle right here. We've got RPQ right there, or what they say is PQR. So that's fine. So that's our starting point right here. And the other one is EDP or PED. So that's the one that goes from here to here to here. Okay. So we have those two. We have those two there, and so we need to figure out whether they are. Now remember, similarity means same general shape and proportionally the same. Okay, so all the angles are the same, and we have side similarity. We have side angle similarity, and we have angle similarity. The reason we don't specify angle side or angle side angle is because we know that if we already have two of the angles, then the third one is true, because in a triangle, if all of the angles are similar, then or all of the angles are identical, then all of the two triangles have to be similar. You guys should have this in your notes. So what we want to do is we want to compare the two triangles and see whether or not they are similar. So we're just going to do a proportion of the sides. So we're going to start off with 20. Whoa, that's much bigger than I expected. It's like, there we go. Okay. So we have the ratio of 22 to 55 equals the ratio of, so we're going to go that bottom 60 minus 36, and that's going to give us 24. 24 over 60 equals 27, or 45 minus 27 is 18. 18 over 45. So notice that we got the 24 and the 18 by subtracting this point right here from this point right here, and vice versa on the other one. Because we know that if the whole length is 45 and this little portion right there is 27, then from P to D is going to be 45 minus 27. So we then reduce them. 22 divided by 55, we can pull an 11 out, and we get 2 over 5, looking good. 24 over 60, we can pull a 12 out, and we get 2 over 5. Hey, so far so good. And the third one, 19 over 45, we're looking for 2 over 5 here. So what we do is we pull a 9 out. We get 2 over 5. So notice how all of these are identical. Therefore, they are similar, and they're similar through side. And notice that we could also say side angle side, because P right there is the same angle for both of them. And if we were doing this via proof, we would use the reflexive property. Angle P is congruent to angle P. So it's going to be C. Looking over. Okay, so now let's clear that off. clear all the drawings. Stop the annotation so we can move this down. So here, notice that we only have two angles, and we see that we only have two sides, and we see that two angles are similar, and then these are 30 and these are 25. So these are going to be the same. So really the thing here, it's going to be side angle side, but what we need to do is make sure that we're matching up the right sides. So here, if we go from V to W and then W to U, so we have W, sorry, let me undo those. So we know that, nope, redo the undo. So what we know is that we're going to, so this is, say, it says WBU. So we're going to go from the angle down to the 30. So we like, oh, because I need to click on that. Cool. Okay. So if we're walking, we'd go here, down that 30, down the unmarked side, and then back up to 30. So here we have JLK, JKL, or KJL. And honestly, it could be either one of these two. They're both going to be right because we're starting at J, we're going down at 25, down the side that has no marked, and then back up at 25. Otherwise, we would go JLK, we go here, here, and then back up to 25. So either A or B is correct, and those would both give us side angle side. So let's exit annotation mode. That's disconcerting. Okay, so let's do these two. Let's clear the drawings. Annotate, clear. Okay, so 7. Again, we have angles here. And so we have two 56-degree angles. So right away, if I'm looking at this, I can get rid of A, because A says side, 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 and we don't have all sides. So what I'm really looking for here is I need to go short to long, right? Or short to short, long to long. So I'm going to go, is the ratio of 36 to 78 the same as 72 to 157? Now, that looks like an awful lot of math that I just don't want to do in my head, and reduction that seems like it could take a long time. So I'm going to pull out my handy-dandy calculator. Eventually. Give me a second. My phone's being silly. So 36 divided by 78 gives us 0.4615. 0.462. And when we do 72 divided by 157, we get 0.4585. So that gives us 0.459. Are those two equal to each other? No, they are not. No. Okay, I'm supposed to be like doing this big dramatic X right there. And it's just not letting me. Instead, it just has me put, oh, there we go. Okay. So because those are not equal, even though they share one angle, they're not similar. Moving over to number 7, or number 8. Again, let's clear everything off. Here we have two 74s, and then because those are bow tie angles, see right here? See how the bow tie goes cross right there? So I call them bow tie angles. They're actually called vertical angles. So we know that EKF and MKL are identical. They're congruent. So this gives us similarity. So KLM, we're going from that center angle to the 74 to the M. So here we want to go center angle, 74 there. So we want KEF. So that's going to be B. Notice EKF would not give us similarity because order matters. And so if I said that EKF and KEF are the same, then what I'd be saying is that angle K or angle E, and then on one triangle, that 74-degree angle is congruent to the angle K on the other one. And I don't know that for sure. So, okay, moving on. So we want to clear that out and truck forward. Nope, close. Okay, so for these ones, notice here you're given multiple choice, how they're similar, and complete the similarity statement. In these next 4, we're being asked just to determine whether or not they're similar, and if they are, then complete the similarity statement, annotate. Okay, got the draw going. So here, we know there's an angle here, and then what we're trying to look at is whether or not the sides are proportionate. So remember, we go, is the short on one of them, the ratio of short to 1, equal to the ratio of short to long on the other? Now notice here that both of them, 5/12 doesn't reduce, but 10/24 does in fact reduce. I can pull a 2 out from each one of them, and it gives me 5/12. So 5/12 does equal 5/12. Therefore, the sides are proportionate, which means that we have side angle side proportionality or similarity. So we're going CDE. So we go from the short side, we go from the angle, that similar angle, we go down the short side, down to the unmarked side, and then back up the long side. So when we're writing our similarity statement, we need to make sure that we follow that same pattern. So it's going to be similar to triangle. We're going to start at the known angle, F, go up the short side to G, and then go down the unmarked side to H. So CDE is similar to FGH. Looking over here at number 10, again, we see that we have two isosceles triangles here with a common angle, so they are going to be similar via side angle side. And here we have TSR, and we can honestly go either way. We can go FHG or FGH. Either one is acceptable because either one, because they're isosceles, and if you guys remember, when they're isosceles triangles, we know that these two angles are identical. So those two angles are identical, which means that they're going to be naturally congruent to these two. So it really doesn't matter whether you go FHG or GFH. A cool thing about isosceles triangles. So let's clear these off. Exit annotation. See, getting pro at this. And let's look at 11 and 12. Go back up, restart the annotation. Okay. So 11, we have LKJ. Okay, we have LKJ. And what we're going to do with that is see, so that's the big outside one. We're going to see if LUT is the same. And it is. So we see that because if we were to break this out, we'd have LJK is the big one, and then that little triangle up top would be LUT. So notice that L and L, those are the same angle. So we have one angle point. We have no side lengths here, so we know really what we're going for. It has to be angle-angle similarity. And the only other piece of information we're given is that UT and JK are parallel. Well, because they're parallel, that's going to give us this angle right here, U, and this angle right here, J, as being congruent. And that's because if we were to draw, and if, going back a ways, we're to draw two lines that are parallel and cut by a transversal, that this angle right here and this angle right here and this angle right there, we go, would have to be congruent because they're alternating, or same side. They're not. They're corresponding. So we have corresponding angles here. So that would set up angle-angle similarity. And so LKJ, we're going to go down the right side to make sure we hit the corresponding angles. LTU, triangle LT. Okay, number 12. Here we just have three sides. And what you can do is really just look at it and see that each side is 10 times bigger than the other one. So the ratio of each one is going to be 1 to 10, 1 to 10, 1 to 10, 7 to 70, 9 to 90, 14 to 140. So side similarity, we got this. So DEF, we're going to go up the 7 side. So we're going to start at U and go to V. E to F, we then come down the 140 side and go V to W. And that's going to match everything up. More do we have here? No, not too much. Don't know that we're going to get through all of this today. So all of the following triangles are similar. Solve for x and then solve for the missing side length, 4 points each. So we know these are similar, right? So what we want to do is we want to basically look at these and go, okay, if they're similar, then the ratio of the sides has to be the same, which means that the ratio of 60 to 108 has to be equal to the ratio of 70 to 10x minus 4. Okay. So what we would do is, 5% left on my battery, on my tablet. Don't worry, I'll still be able to keep going even if my tablet dies. Okay, so the 60 divided by 108, what we can do is we can sit there and let's just do it the easiest way. We're going to cross multiply. Okay, so 60, that gives us 60 times 10x minus 4. 10x minus 4 equals 70 times 108. Okay. 60 times 10x gives us 600x minus 60 times 4, 240. And this is going to be 7,560. So what we're going to do is we're going to add 240 to each of these. So we'll solve for good old x. We're going to add 240 over here. So this gives us 600 x equals 7,800. Divide both sides by 600. Notice the zeros cancel out, so we have x equals 78 divided by 6, which is 13. Okay, that's step one. We then need to go back up, plug it back in. 10 times 13 is 130. 130 minus 4 is 126. Okay. Um, 14. Notice we have two isosceles triangles here. So this is actually really easy. Since we know that they're isosceles triangles, we know, so because why? How do we know that both of them are isosceles triangles? Because they're similar. We're being told they're similar. And since one of them is isosceles, the other one has to be isosceles too. So we don't even need to do the proportion because we know that x plus 16 equals 30. So I know the length of this side, just by checking it out, is 30. We subtract 16 from both sides, and we get x equals 14. Easy peasy lemon squeezy. Okay, so we're going to clear this. We're going to exit annotation so we can scroll down to the next set of problems. And there we go. Okay. So for 15, we have two sides. We know that this is side angle side. This is very similar to the one that we did earlier. And so what we're going to do is we're going to set up this ratio of 40 to 16. That's the total, the long side versus the short side, equals 2x plus 22 over 20. So we can reduce these a little bit. On the left-hand side, 40, 16, both have an 8. The top one is 8 times 5. Bottom one is 8 over 2, or 8 times 2. So this turns into 5 over 2. That's the basic ratio. That's a scale factor, 2.5. Equals, and we can actually pull a 2 out of all of this. And so we end up with x plus 11 over 10. And the reason I did that is just because it makes the multiplication easier. Now when I cross multiply, I'm going to get 50 equals 2 times x plus 11. Now before, I would have gotten 40 times 20, 800, equals 16 times 2x plus 22. So this is then going to give me 50 equals 2x plus 22. Subtract 22 from both sides. We get 28 equals x, sorry, 2x, or x equals 14. Now here's kind of the cool thing. I don't even need to know, so I already saw for x, which is part of the problem. But check this out. Right here, I have 2x plus 22 equals 50. So I know that equals 50. I could also plug 14 back in. 14 times 2 is 28. 28 plus 22 is 50. So here we know that GFE is similar to GML. So what we're going to do is we're going to set these up. Make sure you do it right. So GF, notice the GF right here, those first two, has to be set up opposite GM. So we're going to go 182 over 8x minus 2 minus equals 117 over 45. Left-hand side, we can pull a 2 out of everything. It's going to give us 91 over 4x minus 1. Notice how everything gets that 2 pulled out. You can do this without it. If you have a calculator handy, it might be easier just to go ahead and cross multiply the 182, the 45, everything. And that's going to equal. And the other one, I can pull a 9 out. Again, this is something that you guys aren't going to probably know because you just don't. Because when we talk about things like how to find out whether things are divisible by 3 or 9, a lot of you guys just kind of tune out. But anyway, here's how it goes. If you add up all the numbers and that number is divisible by 9, the whole number is divisible by 9. So 7 plus 1 plus 1 is 9. 9 is divisible by 9. 4 plus 5 is 9. 9 is divisible by 9. So I know they're both divisible by 9. 117, when I pull that 9 out, is going to give me 13 over 5. So now I'm going to cross multiply. 5 times 91, 455. Which I know it's big and ugly, but it's a whole lot better than 45 times 182. And then here we have 13 times 4x minus 1. I have to move that in a little bit. So we have 455 equals 4x times 13. So 4 times 13 is 52. So we have 52x minus 13. Okay, so we're going to add 13 to both sides. So we get 468 equals 52x. We're going to divide by 52. And we get 9. So x equals 9. When we go and plug that back in, 9 times 8 is 72. 72 minus 2 is 70. Okay, so I'm actually going to skip these next 4 right now because they're more the same and I want to get the scale factor. So the polygons in each pair are similar. Find the scale factor of the smaller figure to the bigger figure. So the ratio of the smaller one to the bigger one. So because we know they're similar, we can just do one set. So what we want to do is we want to do the ratio of the smaller one to the bigger one. So we're going to take the 2 short sides. We're going to go 15 to 18. We reduce that so we can pull a 3 out of each one. We get 5 to 9. 22. Again, we want to go short to short, medium to medium, long to long. So here, if I were to take the long 18 to 24, each one of those I can pull a 6 out of, so that gives me 3 to 4. So notice if I went short to short, that'd be 9 to 12. I can pull a 3 out. Again, I get the same thing. 23. So notice here that we have to look at which sides match up. And the sides that match up are the 8 and the 14. Because the 8 would match up to this side right here. Okay? Because we'd want to rotate it kind of this way. Or rather, we'd rotate the larger one clockwise, and that way we could overlay it. Actually, I did that wrong. Because if we did that, we'd end up backwards. So let's go undo, undo, undo. So it's actually the 8 and the 4 that match up. And how I can tell is if I kind of mentally rotate this one this way to where it would line up, notice that this point right here would be higher. So when we put that 8 and 14 one, the one on the right, when we put that up and down, we end up with this point not matching up with this point. So see on the left-hand one, the vertex on the right-hand side is higher than the vertex on the left-hand side. So that's what we want to do. We want to make sure that when we rotate the larger figure, that the vertex on the right-hand side is higher than the vertex on the left-hand side. And by doing that, we actually have to rotate it all the way like this. And that gives us 4 to 8 or 1 to 2. One more. I've got 2%. We got this. Where's my mouse? Where's my mouse? So we're going to clear everything. Exit annotation. Go down here. Restart the annotation. So keep in mind that when I'm rushing, it's just so I can use my tablet and like my computer's plugged in, so I'm good. So notice here we have our 3 sides, right? So again, Coco, no, the dog wants to get out of the room. So we want to make sure that this point right here matches up with that point right there. So we'd have to rotate this one about 270 degrees this way to get that to match up. And when we do, what we see is that this 13.8 and the 6 match up, and then the 12 and the 6.9 match up. So those two match up, and those two match up. So if I were to sit there and go the ratio of 6 to 13.8, and I wanted to reduce that, I could actually pull a 2 out of both of them. 6 divided by 2 is 3. 13.8 divided by 2 is going to be 6.9. And that would be it. So hopefully this was good for you guys. I really would love to see some of your faces. So download Zoom or go to zoom.com. I emailed each and every one of you guys the invite. That invite's good for every single geometry class we're going to have. Every Tuesday, every Thursday, 10 a.m. I'll be here. I'll be recording it. And when we're done, I will be converting it and posting this to YouTube. And then I'll link this, the YouTube video, in the Google Classroom. So you just got step on step on step on step. You're never getting away from me, guys. Love you all. Take care. Stay safe. Stay sane. And I will